This conference will now be recorded.
So yesterday we were discussing on classful IP addresses, and we also discussed how we can divide a subnet into, or in other words, how we can divide a big network into smaller networks, right? So this is what we ended our discussion yesterday, right? So okay. So are you able to see my screen? Okay. So right. So anybody having doubt before I proceed ahead? Right. So yesterday we were discussing on the subnetting, right? So subnetting is basically if we have a big network like this, right? So it means how many IP addresses? So this will be a common question. So they will give you an IP with a CIDR value and they will ask you how many IP address you will get, right? So this value whatever we have, you have to just subtract from 32, and the like 32 minus 24 we get 8, and you have to calculate the power 2 to the power and whatever the answer we'll get after subtraction. So we'll get the value. Okay, but that value will only tell you how big your network is. So a duty of a solution architect or a AWS cloud engineer or a DevOps engineer, you should be able to tell them, so these many IP addresses are there. So as per our requirement, into how many sub networks or how many small networks we can divide, so that we can fully use this in a more protective manner, right? So because what so happen in every organization, they will not dump everything in a big network. So there in organization there will be a habit of, you know, naming things as per the environment, like test, then dev is a abbreviation for development, then UAT is abbreviation for user acceptance testing, then pre-production environment, then production environment. So usually these are the environments you will definitely find. So along with that, there might be other environment as well, like SIT, that is system integration testing. Okay, pre-UAT. So it depends on organization to organization, right? So when we have this type of concept, so we have a habit of dividing the network into small sub networks, so that we can dedicate, okay, we are dedicating this subnet to this, and we are dedicating this subnet to this. Okay, so today we are going to explore this concept. So we have a requirement, and based on that requirement we are going to divide. Okay, so let me take an example. So yesterday we were discussing on, from classful IP addresses, we are now in the era of classless interdomain routing. That means there is no restriction to use this at all. Okay, this calculation and everything, it remains the same, but only thing is you don't stick to these numbers. You can use 20, 15, any number you desire, right? So in organization, they'll give you a requirement. Say they'll give a IP ranging from 10 to 100.204.0 slash, or they will give you like this. Now let me take a big network, in the sense 10.100 or 10.200.0.0 slash 16 they have taken. So why this value? Because please note, slash 16 is the maximum, CADR supported by any cloud. But as we are learning AWS, I'm going to mention AWS. So in any network which you are going to create inside AWS, the maximum value they're going to support is slash 16. The reason is slash 16, how many IP address you'll get? Definitely we'll get 65,536 IP addresses, right? So these many IP addresses we'll get. So beyond this, AWS does not support. So please remember, so this is the maximum. Okay. And what is the minimum? So the minimum CIDR range can be /28. It cannot be 29. So what is 28? How many IP address will get? So /28 in the sense is the lowest CADR supported by AWS, because here we'll get 32 minus 28, that is how much? 4. So 2 power 4 is 16. So we'll get only 16 IP addresses. So IP address I will mention here, IP, right? So it, apart from this maximum and minimum, the number can be anything in between this /16 to /28. And please, as you can notice here, the higher the value of the CADR, the less number of IP addresses you will get. So this thing you have to keep in mind as a as a shortcut. You can remember this way. Okay, and the lower the value, higher number of IP addresses you will get. Okay,
Sir, ಅದು
so now
ಇನ್ನೊಂದ್ಸತಿ
let
ಹೇಳಿ ಸರ್ ಅದೇನು.
yeah, sure.
ಹಲೋ.
See, yeah.
ಸರಿ ಸರ್.
See, in organization, if they give you any IP addresses, okay, so they'll give you this IP range. So they'll say, hey Mithun, we'll give you the IP CADR range, and they'll ask you to design a network initially. So you have to tell them, okay, so /16 is the maximum CADR supported by AWS. So in simple words, in AWS, in any network, okay, in one network, maximum 65,536 IP address you will get. So this is actually one extra 5 it's added. Yeah, so this is 65,536 IP address it can support in one network. Isn't it? So maximum is 65,000 plus IP addresses, and minimum is /28, the side CADR range. Okay, so this CADR range determines the amount of IP addresses your network is going to have. So if you select this /28, so you will have only 16 IP addresses, meaning you can spin up servers only 16. Is it clear? So this is just a maximum quota, or you can say maximum limit provided by or supported by AWS. Okay, now let us start with this. Okay, now they have given, now their client will give you this IP addresses. Okay, so given by client. Okay, so client will say, so this is my IP say CIDR. So I have 65,536 IP address they'll give. Okay, now they will have a requirement. So what requirement they'll give? So they will say, Mithun, I need 5 subnets or 6 subnets in such a way that each capable of storing some 1,000 servers or 1,000 resources. So this will be the requirement provided by them, and they'll give you this. So you can, they will not restrict you, they will ask you to use any CIDR I want, but the requirement is 1,000 each, because nowadays we don't launch thousands of servers, because now we are already in a microservices architecture. In a very rare cases, we will spin up thousands of servers in a one go, right, or in any environment. So there will be very limited number of resources nowadays. Okay, so now you will think, so 1,000 means, so okay, now they have not given, okay, this is your network. Okay, so this is your network. So how will you divide? How we can divide? So this is the question, right? Network is having 65,000, but how will you divide? On what criteria you will decide? So you have to decide on the concept of binary. So what is the key here? So 1000 per subnets. They want a 6 small networks or subnetworks, each capable of holding 1000 resources. Now your calculation should start like this. So you start by 2000, 2 power 0. You start from 2 power 0, or I have already told you that 2 power 4 is the minimum network supported by this one, isn't it? So you have to calculate the 2 power in such a way it should be equal to 1000. So what is 2 power 4 and 2 power 5? 2 power 4 is 16, 2 power 5 is 32, and 2 power 6 is 64. So similarly, you keep calculating until you get 2 power how much? So calculate 2 power 12. Let us calculate. So what is 2 power 12? Can anyone calculate quickly? Anybody? Okay, so 2 power 12 is 8192. So which is too much. Now, so we need to calculate for 2 power 8. So let us calculate for 2 power 8. So what is 2 power 8?
Sir, 2 power 12 is 4096, sir.
Okay, 1 minute. Okay, 2 power 12 is 4096. Correct. My bad. Okay. So 4096. So what is 2 power 10 then?
It seems 1024.
Yes.
Uh,
So 1024. So 2 power 10 is 1024. Now this is matching to our client requirement. Okay, so this is matching. Okay, so 2 to the power 10 is 1024. Okay, so if I value, I got this value. Then what will be the cider range then? So simply subtract 32 minus 10, this value. For what value you have got this 1024, right? So calculate this. So how much you will get? 32 minus 10 will be how much? 20. So our first subnetwork will be, I'll mention here. So 10.200 0.0/22. This will be your subnet 1 or subnetwork 1. Okay, usually subnet 1 is better, isn't it? Because /22 means again you reverse calculate. 32 minus 22 is 10. So 2 power 10 we are getting 1024. So which is matching with the client. So given by client is what? So we need to configure 5 subnets, each capable of holding 1000 IP addresses. Yeah. So we have achieved this. So /22 1024. Now then what will be the value of my second subnet then? Can anyone tell me based on the yesterday's exercise? See, you can compare this one. See, the first subnet was 192.168.101.0/25, and second one was 192.100.101.128. So what will be my second subnet one then? So the second value will be this 10.200.
20 0.0 by 20.
No, not 0. Why 0? We have already given 0, no? Subnet 1 it is already taken.
Okay.
See, you compare this one. So 101.192.100.101.128/25 means to here, from here to here, correct? So if we have already given this to the subnet 1, then how can you give the same set of IP address to the subnet 2? So you need to calculate the range like this until you get 1024. Are you getting, or you are getting confused? See, 1024 means from 10.200.0.0 to 10.0.3.0/22. So this will be the range of subnet 1. This is not subnet 2. This is both are subnet. I mean the range I am talking. Can you notice one thing? The third octet is changing frequently. Why? Because see here, for the subnet 1, my IP address will change from 10, start from 10.200.0.0 till 10.200.0.255. So how many IP address? This range 256. Clear? You're getting it? 10.200.0.0 to 10.200.0.255. Any bit, the value cannot be more than 255. Why? We already discussed, because the maximum value is 255. Yesterday, I mean last class only we have discussed. The maximum value is all can be 1. That is, if you add everything, it will be 255, and the minimum is 0. If all the values here is 0, correct? So that is why any IP, any network will start from 0.0 and it will end here. But we have only 256 address. So that is where the third octet will come into the picture. So 10.200, then 1.0 to 10.200, 1.255. Again 256 IP addresses. Again 10.200, 2.0, 10.200, 2.255. So 256 again. So how many are there? 250, 250, 250, almost 750. So we need one more, correct? So 10.200, 3.0 to 10.200, 3.255. So now 256. Now if I calculate the value, how much we are getting? See here, sum is 1024. Now this is our entire subnet 1. I will highlight in green. Now this is our subnet 1. Okay, so this is subnet 1, the range. So now, as per this, my subnet 2, the value will start from 10.200. So let me write here. So 10.200.4.0. Okay, it is, the color is changing. So let me write here. So 10.200.4.0 slash how much? What is the value we are taking? So 22. Because again we need 1000, right? Let me change the color. Yeah. So now my range will start from 10.200.4.0 to, okay, I will change the color later. It is taking the 10.200.4.255. So again 256, 10.200. So what will be the next one? So 5.0, 10.200.5.255. So again 256 IP addresses, 10.200, 6.0, 10.200, 6.255, again 256, 10.200, 7.0, 10.200, 7.255. So 256 IP addresses. Is this clear? So this is my subnet 2. Clear everyone? Yes,
Yes, sir.
no?
Yes, sir.
Clear, right? Okay. See, this is very easy once you understand, right? Once you understand the concept, it becomes very easy. So like this, I have divided into two subnets. So like this, you keep on going. So you can reach until the third octet reaches 255. So that is the maximum. Okay, if you get stuck in between, there are some tools available to help you also. Okay, it doesn't matter. So let me show you those tools as well. There is a website called CIDR.xyz. Okay, so this is a good website. If you're getting stuck anywhere, if you just give the CIDR range, it will calculate and give you. So just check our requirement. So 10-200, this is what I gave, right? 10-200/16. So 10-200 0.0/16, isn't it? So give here, it will tell you. So 10-200 0.0/16. Now it will quickly, within a fraction of second, it will calculate. See, the first usable IP, then the last usable IP, the count, right? And our formula 10.0.0/22. So see, clear na? This is matching 10-200 0.1, 10-200 3.254, 1024 count, correct? So 0.1 to 3.254. So same thing we have calculated here. See, 3.255. Clear? So you can easily calculate if you are getting stuck. So that is what I meant. If you use, see, in the classful IP addresses, there was a restriction. You should only use /8 or /16 or /24, but it's not like that. Here you can use /20. It means this is this whatever I have highlighted now until here. It belongs to the network bit. Okay, so 15. So you can go up to 10-200, 15.254 is your last IP addresses. So this is the meaning of classless, meaning you can borrow from the next available octet. How many you want, it is up to you. So if you use the first and second, it will be /16. If you use this one, then it will be 17. The first two 18, 19, 20, like that. So in this manner, you can calculate anything. Okay. Similarly, I told you the /28 is the minimum, right? It means from here to here, it is a network. We cannot, allocate this to any host. So only these 4 bits you can assign. So 4 bits means how much? 8421, right? So like this you should remember. So 8421. So maximum is 16. Clear? Yes, no? Okay. And there is another website also. If you are getting stuck, there is a subnet calculator also. You can divide using this website. Okay, but before using these, it is always recommended you calculate on your own, right? So for example, Wait a minute. I'll give you one more, this one. Yeah. So if you give any IP addresses, it will calculate. So let us take our requirement from this one. So 10.200 0.0/16. So 10.200 0.0/16. So and update. Just a minute. Yeah. Now see here what it is saying. It has already calculated. So the range, your range is, your entire network range is this. See, 10.200 0.12, 10.200 255.254. Within this range, your 65,000 IP address will come. Now you can start dividing like this. So if you divide, you will notice that this number will be increasing. See here, so 17. Now you again divide 18, 19, 20, 21, so 22. So this is our requirement. So this is our subnet one. Same calculation what we done now. So we'll get it. So now we have only how many? 2. So what is our requirement? We need 3 more. So divide again this one. So 1, 2, 3, 4. So divide here. Yeah. So like this. So 1, 2, 3, 4, 5. So we can stop here. You're getting it. So these two are very useful website if you are getting stuck. But I don't need, if you practice this like 5 to 6 times, easily you can calculate any CIDR value. It is not that difficult. Okay, but you can use this if you are getting stuck. Clear? So this is how we can divide the subnet in a bigger network into small network. Why? Because this we will give to some components and this will give to some UAT or some, this is pre-UAT, like that we can do it. Okay, so this is just the idea, nothing else, so that our routing becomes very easy. Clear? I will share these links with you in the group, right? Okay, is this clear, guys? How we can divide the subnet? And you can
Yes, sir.
calculate the subnet mask. No, nowadays nobody asks you to calculate the subnet mask, but you can calculate. For example, if the /22 is your CADR, so /22 means how many you will take? So /22 means first 2 octets, that is 8 plus 8 is 16. Then in the third octet, the first 6 bits you will use. So 16 plus 6 is 22. So if all these 22 bits are 1, then what value will get? So 255.255. Then the first 6 bits, that means this. So from here to 1, 2, 3, 4, 5, 6 here. So how much? So calculate. So I think 240 it will come. Anyhow, let me calculate. 1, 2, 3, 4, 5, 6. Yeah. The sum is 1, 2, 3, 4, 5, 6. So 252. Correct? So 252. See? This has already calculated, but we should also know the concept. How we got? Because of this calculation. If you add 1 to 6, you will get 252. You can cross check in your Excel also. Okay, so only these 2 bits are dedicated to host. Clear? Okay. So now going ahead. So like this, we will have to divide the network into multiple subnetworks. Okay, so now let me draw and show you to what I was meaning by creating a network inside AWS. Now open the diagram here. Okay, so okay, so think that this is your network. I am symbolizing the network as this. So will you start dumping the VMs like this? So like as a whole inside? No, right? So what I meant was there will be a big network like this, right? So rather than simply dumping all the resources or the virtual machine inside this network, we will divide like this. So this is one network. Similarly, this is another network. They are all belong to the same network, but there will be some bifurcation, like to identify. So this is the 3 subnets. So this is the 4 subnets. And let me write one more here. So this is the 5th subnet. So this is our big network. So copy here. So whatever we discuss, right? So this is our 10.216. Okay, so this entire is our 10.200.0.0/16. Clear? And this one 10.200.0.0/22, this will be coming here. So like this. So this is subnet 1. So this is subnet 2. Let me add one more, then you will get a clear idea. Sorry, this should be 4, not 3. Okay, so 10.200.0.0. So like this. And then inside this, we are going to launch a VM like this. Like this. So this looks very neat. Okay, so we can make this dedicated to some resources, some application, and this we can dedicate it to some other application. So like this, it becomes very ordered. You can easily identify things rather than dumping everything inside a whole network. Okay, you got this idea? Now in AWS, okay, so this network, whatever I just demonstrated in this cloud, right? So this is called VPC. Okay, so from today onwards, it will, you will hear a lot of technical terms like VPC, subnets, routing table. Of course, we are going to discuss each and everything in detail with hands-on, but you should get familiar with these kind of words. Okay, right. So whatever I have represented in the big cloud, so that is called as VPC. VPC is abbreviation for virtual private cloud. Okay, so I am going to draw the VPC now. So this is the VPC. Okay, so please remember VPC is a regional entity. Just a second. So what is a region then? I have explained to you in the first day. It is a regional entity. What do you mean by region? I need answers. Let me go back to the global infrastructure.
Region is a collection of data centers.
Yes, very good. Very good. So region is, I'm just reiterating. See, region is a geographical area where AWS have set up their cluster of data center or chain of data center. Very simple. It is a place in our world map where AWS have set up their business. That's it. To be more precise, or what is their business? To run data centers, right? So for example, in Mumbai, there are 3 data centers. Okay. Now, guys, please go on mute. Right. So now, and it is a regional entity. Whatever we are going to create, the VPC, it is a first. Whenever today, or after this class, I mean after this technical discussion, I'm going to show you how you have to create your own AWS account, because from tomorrow we are going to do hands-on. We are going to be building things from tomorrow. So that is why today or by tomorrow morning, everyone you should be able create their own AWS accounts. Okay, it is free of cost, right? So coming back to my diagram here, just a second. Right, so it is a regional entity. That means you are going to select the Mumbai region. Why I am selecting Mumbai region? Is it because I'm an Indian? No. It is not where you are living, it is where your customer application are being accessed. Suppose if your customer, or if the company you are hired, or the company you are working is based out of India, then definitely you will also set up in Mumbai. If your company is from Singapore, then you have to select the Singapore region. If your company is from USA, you have to select the USA region. That is why we have these kind of regions. Why? Because no client will allow their sensitive data to go outside their country. For example, if you are working for, say, Northern Virginia or any America, okay, so imagine your client is from USA. Now they will, as per their country guidelines, they have a very strict rule that their important data and their customers data should not go outside their country. So that is why they will tell, okay, we have so many, you can use any one. They will give you option like Ohio. Okay, so this is only for AWS Gov Cloud, means it is only for government organization. AWS also provide these cloud services for government organization. So that is where they have separate government region. This region. So they will only allow for government entities, and this particular region we will not be able to use it. Apart from this, these are all for our usage. Okay, now imagine your company is in India, so they will allow you to spin up the resources in Mumbai itself. Okay, so we are all going to select Mumbai. Okay, so you are going to select the Mumbai region, right? Now, so once I have created this, so I'm going to mention the CIDR range also, 10.200.0.0/16. Okay, so this is my network now. So this big cloud I have already set up. Now what next? So our requirement is to divide this big network into 5 smaller networks. So let me note that. So I will use this. So subnet 1, subnet 2, subnet 3, subnet 4, and subnet 5. Okay, so we are going to build like this, right? And each value will be, let me write inside 10 dot 0 0.0 slash 22, 10 dot 200 dot 4.0 slash 22. So like this, we are going to divide all the subnet. Okay, clear? So what will be the subnet 3 then? Come on.
8
10
dot
dot 200
dot 8 dot 0 dot 22.
no
0
4
slash 22.
0 1 2 3 it is taken, 4 5 6 7 it is taken. So you are correct, 8.0 slash 22. Next, correct. Next 10 dot 200
12 dot 0 dot slash 22.
12.0, very good. So 12.0 22, and the last will be 16.
16.
Very good. So 16.0 slash 22. Okay, so does this mean that our entire 65,000 is exhausted? No, we have just used the first 1 2 3 4 5, that is 5,000 change IP address only we have used. So we are going to reserve this for a future purpose if we get requirement in the future. Okay guys, go on mute. Okay, so now we have this situation where we have a big VPC with 5 subnets. Okay, right. Now, so today, okay, so before we start building things, there are several other aspects also that we have to understand, right? Otherwise, okay, so let this blueprint be here. So based on that, we will start building from tomorrow, or maybe because you don't have your own accounts. Okay, so from tomorrow we'll start building. But before that, let us try to understand the difference between, now every devices will have a IP addresses, correct? Now each device will have a two set of IP addresses. Okay, now you may be thinking, what is this two type of IP addresses? One is to communicate with internal resources, and the other one is to communicate with the internet. So this is very, very important aspect. You should all remember. So that is why let us go back to our setup. Okay, so let us leave this VPC here. It now let us understand this concept. So this is you, right? So this is you. Now you have your laptop. Yes, so think that this is your laptop. Perfectly fine. So once you log in, and if you just type here, you will have a IP address. You just type IP. This we have already discussed, right? So this is the set of IP addresses. So these IP addresses are useful to communicate internally. Okay. Now coming back to the another concept. If you take this laptop, okay, you have IP address, everything. So will you be able to connect to the internet as it is? Is it possible? What else is required to connect to the internet? What is required? So you need a router, right? You need this router. So which is provided by a external provider. It can be from say, for example, I am using Act Broadband.
Any service provider, sir.
Yeah, any service. It can be a Geo also, doesn't matter. So you just need a gateway to connect to the internet. So what will happen is this router is connected to the internet. So now I'm going to see, I always like to represent internet with cloud, okay, because it becomes easy to identify things. Okay, so this router gets connected to the internet and we connect our laptop, right? So via this router we can access any website we want. So you can access Google, Facebook, or your anything, Gmail, etc. That is because of this router, right? But what will happen is, suppose you have your mobile phone also. You have your mobile phone also. Okay, so you have connected to this device. You have one desktop also. Yeah, so this is your desktop. Now this is also, you are connected to this router. Now, so these will have their own set of IP addresses to communicate with the, internally, if they are connected via LAN cable. Okay, but the moment they are all connected to this router, so they are exposed to the internet, or in other words, they will be able to contact any website in the internet using the public IP. Please note this point. Public IP provided by the ACT broadband. Okay, so for example, see here in the output, do you see anywhere the IP? So now just go to your browser and just type what is my IP addresses. Just a second. So what is my IP addresses? Now this is the IP, but do you see this 106 IP anywhere printed here? See 106.51.240.255. Do you see? No, we have only how many adapters I have? I have one Ethernet adapter which is showing 172.27.64.1. Then another I have Ethernet adapter, Ethernet, that is it is showing it is taking the IPv6 address. So this is also another address, and one another for wireless LAN, it is having this address. But nowhere it is showing the 106 IP address. Why? Because that is not attached to your operating system or your laptop. The IP address which the browser show is the IP of the internet service provider. So that IP will come here. So any devices connecting to this router will automatically get this public IP. Any number of devices you connect, you can check, you can cross check after the class, or even now if you are connected, if you have connected two devices to your Wi-Fi, you just check your IP address in both the system, it will be one and the same. Why? Because the internet service provider give only one IP per router, because as there are more number of users, the public IP is, we are falling short of public public IPs, because every public IP should be unique all over the globe. Private IP is different. See, whatever we are going to create inside, that is entirely different. All organization can create the VPC with the same ranges. It doesn't matter, because this is whatever we are going to set up, right? That is for the internal communication. That is totally fine. In your laptop also, you may also get the same range. That is different concept. But if your devices need to be connected to the internet, then you should have the unique public IP that is managed by your internet service provider. And once you switch off also, that is why you might have noticed that once you switch off your router and switch it back on, you will notice that this IP would have changed. That is why, because there is a shortage of public addresses, and once you switch off, they will take back your public IP when there is no need. Okay, so that is why you have to be very, very careful when you are managing with the public IP in the AWS network, right? So that is why public IP, so you should know the difference between what is meant by public IP and what is meant by private IP, isn't it? So in simple words, if I have to say, see, there are, imagine that two layouts with the same name. Okay, say AWS layout. So there are two AWS layout in Bangalore. Okay, and their structure is one and the same. Both the layouts is having 100 houses, 1 to 100 and 1 to 100, same housing number, but they are both are in different localities. So one is in Vijayanagar and the other one is in Kormangala. Just imagine, I'm just giving an example. So if you are inside your layout, so I can easily identify which is house number 99, which is 95, easily I can reach. But what if I have to reach house number 95 of Kormangala layout, then will I just write the door number or the flat number 95 and just post it, will it reach? So I have to be more specific, right? I need to enter the pin code, everything, only then it will reach. So that is the difference. Okay, so you should have that understanding. Okay, so if you have to reach the outside apart from your internal thing, you will be required a public IP to get access to the internet. Is this clear? So this is the concept of public IP, and this is totally managed by your internet service provider. Okay, that can be your Act, Airtel, Vodafone, any other vendor for that matter. Is this clear? Right? And all the devices will share the same IP address in order to connect, because this will forward the request to this router, and this router will hide the IP address of this, I mean whatever it is using, this IP, and it will contact these servers and get the information, and it will serve the web contents or the web application, which we can see now, right? Okay, so let us start now okay, we will start the process of creating a free tier account. Okay, so how we can create an account? So go to Google and type AWS free tier account, right? So click on free. So click on create a AWS account. Right? See, yeah, 1 minute. I already have account, so it is bypassing that. So let me go here in the incognito mode. Okay, so free AWS free tier AWS account. So click here. So create a free account. See, there are few things you should understand. There are some components which are always free. Okay, and there are some components which are only free for 1 year. Okay, and there are some components in AWS which are not at all free, which I'll be telling you guys. So use only which are under free tier. Okay, see, free trials, 12 months free and always free. Okay, so this information you can get it here. So what are all free, you can read it here. right? Okay, so once you start it will ask for your, why it is going there? Okay, I will give you a document, there it is mentioned. Let me show you that. New account, yeah. Okay, so I'm going to explain in this document, right? I'm going to share this as well. Okay, so you have to go into the console, right? So of course this is a like old UI, so you may feel there's a different, but the fields are almost same. So you have to enter your email address and you have to select the personal. Okay, so it will ask whether you are opening the account for business purpose or your personal purpose. So you have to select personal and you have to enter your email address and everything, and it will ask for the your credit card or debit card details. Please remember it will select only Visa and some MasterCard as well. But remember you should enable the international transaction because they are going to debit 2 rupees INR, 2 rupees to INR for the verification purpose, and they are going to refund in 5 working days. So that is why you have to use your credit card or debit card and nothing else, and you will not be charged until and unless you explicitly tell them. So you should not be worried about your debit card or credit card details. Okay, so once you give the your debit card details, it is going to connect to the Amazon Pay, where you will be debited with rupees 2, and once it is successful, it will take maximum 24 hours so that your account will be in a usable state, right? So you are going to follow the procedure here. It is very straightforward. Okay, it is not a rocket science. So you can create the account. So once you create, right, so for the first time you will be logging in something like this. Okay, so you will get a page like this. Let me show you. Yeah, so okay, 1 second, let me close everything and 1 second. And just enter your password. So once you enter, right, so you will get a console something like this, right? And first you can go to the, you can type here VPC. Today I'm going to explore on the VPC console how it will look like. So this is how a AWS management console will look like, right? And see, this is the region. So here you can select the region. So you can select Mumbai or whatever you would like, you can do that. There is no restrictions that you cannot use. Of course there are some regions you have to those regions will not be enabled by default, so you need to enable them. but you can straight away use Mumbai region. That is not an issue. Now this is how a VPC management console in AWS will look like, and we can see you can start building our resources. Okay, so by default you will notice that inside the VPC section there is already one VPC available, but this will be using the 172 series. If you take any region or any AWS account, this default VPC, so this is called a default VPC, right? So this VPC will always be there, and even AWS uses /16, that is 65,000 IP addresses. Okay, and in the subnet, so I was explaining about subnet, right? So this is so by default 3 subnets will be there. So as you can see, they have used 20 20 20. For my example, I showed you people /22, that is 1024, right? So but AWS will create, you can cross check every account on every region, this subnet will be there. Let me change the region and show you. If I go to Ohio region, this will be same, there is no changes, because this VPC, that's what I meant, that everyone can create the same internal network. See here, 172.31.16.0.20, 171.31.32.0, the same thing, there is no difference at all. See, 172.31.0.0/16. You take any region for that matter, this will be same. You can check the Africa Cape Town. See, as I told you, right? So this, it is not enabled, so you have to enable and start using it. Okay, so we don't need to enable all the regions, so you can pick 1 or 2 regions and you can start. Okay, let me show you. Now this is Ohio, right? So let me take you to okay, so let me take you to Europe, Ireland region. See, same thing. So this is because this is the internal network for only our internal communication. So n number of organization or n number of accounts can have the same IP range. It doesn't matter. But what matters is the public IP, right? And whatever we build, right? So inside this VM can only talk to this VM. This is the internal inside AWS. But if they want to connect to the internet, they'll not be able to. So that we will discuss a little later how we can do that. Just we need a router like this. In AWS also there is a similar type, similar router or a gateway to connect to the internet, that we will explore tomorrow. Okay, so is this clear until here, whatever I have covered, or any doubts? You can ask me now.
No, Mithun. So that will be a NAT gateway, sir, right?
No, NAT is different.
Okay.
This is I mean, this router behaves as a NAT gateway, but this is not a NAT gateway.
Okay, sir.
Here you will have a NAT gateway concept also in AWS. That we have different scenario.
Okay.
Okay, anybody else? Okay, so if there are no doubt, then I'm going to stop the recording.